So yeah, this is Pseudo-Interstitials. I am Tony McNamara from Paramount, and let's dive into it. So first off, what are Pseudo-Interstitials and why? Why is the big deal? Why do I care about this? What was the problem? We at Paramount and a lot of other people in the video industry are doing advertising-supported video on demand, AVOD. That is basically meaning we insert ads, personalized ads, when you click play. You click play, you request the manifest, the server has to go out to an ad service company, Google, Freewheel, somebody like that, bid out the ads, get the ads back, get the list of ads in a VMAP response, go get the ad manifests, stitch them in, have them transcoded, get them beaconized so that you can track how far through they are, and then only then can you return that ad-stitched manifest to the player. So this stuff takes 800 milliseconds minimum to bid the ads, and then there's additional processing time before the playback can start. That's for AVOD with server-side, SSAI, server-side ad insertion. Now there's a lot of reasons why we use server-side rather than client-side. Client-side ad insertion will let you do this stuff later. It'll let you do it in parallel, but it requires a thick client. It requires a client that has a fair amount of power and 2 decoders generally, because it's going to do these things and flip them on separate canvases. So you run into serious device fragmentation problems. Amazon Fire devices give you grief all the time. A lot of problems with Roku devices too. So it's anything that's too low powered, you're going to get some grief on those, but also just different code. So SSAI is where it's at for companies like us right now. That may change in the future. And so for SSAI, that's the process you go through. What we want to do is move this process out. If we can move this process out, we can get more time for bidding, and that more time for bidding, faster startup, but also fewer ad orphans, because we can do fewer ads at a time. And what that means is this. If you're watching Maverick, it's a 2-hour movie. Suppose you start watching Maverick, and then dinner's ready, and you take an hour to eat dinner, or half an hour, or whatever. You take a phone call. By the time you make your way all the way through Maverick, it might have been 3 hours. Those ads might have already expired. You're still going to see them, but we don't get paid for them. If you stop watching Maverick entirely, the ads at the end are orphans. They don't get played at all. We don't get paid for them. But we already bidded them out. And that reduces our cost per ad for the ads that do play. We also want there to be less time between when we bid them and display them, because that increases the advertising revenue, because advertisers will pay more for that. So there's a bunch of benefits to moving it out. But how do we do that? Now, some notes for the rest of this presentation. I'm going to show things in HLS because it's easier to show it. They work just fine in Dash 2, but Dash's XML manifests are a lot harder to show things in. And just because you can do something does not mean you should do it. Some of what I'm going to show you will be a really bad idea. So I presume everybody here knows most of this, but just as background, periods and discontinuities. This is how we stitch ads for server-side ad insertion. Basically, this is your chunk list, your media playlist. And you have the beginning of the chunk list and a bunch of chunks here. Video1_0.m4s, video1_1.m4s. And all the way down, you'll see that in my demo, the first 6 minutes takes 72 segments. Then your discontinuity, and you start a new video. This is your ad in this case. Video 2:01, and so on. And then you can resume the other video with another discontinuity and then go for 73, 74, 75. That's all it takes, as long as they're using the same codec, and you want them using roughly the same resolution and bit rate. That's important so the players don't crap out. In Dash, the equivalent is period with an embedded adaptation set and representations, and again, that's why I'm not showing you Dash. Works fine, just not so easy to show. Interstitials. So remember, the topic of this is pseudo-interstitials. What are we faking? An interstitial is basically those chunk lists you saw in a separate URI, a separate file that you can reference in the manifest. HLS calls them interstitials, and here you'll see they're actually just a part of the date range class. Apple extended it. This exact string, this string right here, you will see all over the web because that was in Apple's initial documentation, and so everybody just copies it. Dash has XML linking language, or X-links. They do the same thing. They actually do it more elegantly than Apple does, so that's nice. The challenge is that this was only introduced about 4 years ago. It's trickled out. Apple, a year ago today, still hadn't released any consumer-facing players that supported it. So we have, again, device fragmentation issues. So especially for a company like Paramount, where we have a lot of advertising in overseas markets, Latin America, South America, and so on, the devices there are low-powered and seldom updated. We won't have interstitials there for a long time. So that means we need a way around that. The other challenge is that using these interstitials is great if you can, but it doesn't solve our late binding desire for ads. So let's solve that problem. This is what I mean by making it pseudo. Here's your chunk list again. And here's number 72, the last one of the segments before 6 minutes where we put the ad break. There's our discontinuity. I'm pointing this to a server. Now in my code that we're running on my laptop here, it will actually be localhost 8082 because, hey, it's running on my laptop. I designed it to run on anything. It runs perfectly on a CDN edge. When the demuxed presentation is done and I put up the GitHub repo, you will see that we have code to run it on a Fastly edge just fine. So, you could omit this if everything is relative and running on the CDN. You don't need to put the host name in there if it's the same host. This is a token. In this case, it's up there. It's the second thing, a token denoting a placeholder key. It's just to let us know that in this segment's case, we're going to do a replacement. If we don't see that token, and it's a much longer token in the real world, you're not going to have it that short. It just doesn't fit on the screen if it isn't that short here. And then add break 1_1, that's this, the placeholder pattern. Break number, add break _ segment number. That's all I've done here. Now in reality, you're going to want a GUID there because you're going to have hundreds of thousands of users getting ads at the same time. Each user will have their own GUID, and maybe you do it by ad break. There's going to be a bit more trickiness to this. It's important to realize also, though, that your ad breaks have to have separate numbers because you're going to give the same segment to multiple ad breaks at a time, and you have to be able to know which ones they are. What will happen, as you'll see on the next screen, is we'll take these, send this out in the manifest. The client sees this, and then we'll resolve them at the CDN or server edge on the fly, and it'll get plugged in. And here's how that works. This reader server that I refer to, I'm going to show you that code. That's 300 lines of code right now. It runs, again, it's tiny. The code that I've got is written in Go. The CDN edge code that you'll be able to download from Git is written in Rust, so you have your choices. Doesn't matter what language, it works in VCL. Not the easiest thing to do in JavaScript. But all it's doing is we get the manifest, we stitch in the template keys that I've just described, and that's actually not part of my server code. We have a different server for that. When the playback starts, you get that custom manifest. As soon as the playback starts, the server here can go out and bid the ads. Now what we're going to do is decide them on the fly, unless you want to see the canned demo, but I don't think you want to see the canned demo. And then we map them and send that to the Edge dictionary. In this case, the Edge dictionary is the reader server. When the manifest chunk request comes in, we look up, does it have that token? If it has that token, we map it and we send a beacon. The reason we send the beacon is because we need to lock that entire placement opportunity or ad break. We don't want to change that one anymore. If we have 5 ad breaks, we're deciding them all and giving them all the same ad initially. Then one gets locked in with that ad as soon as we see that beacon, and the other 4 get a new set of ads bidded. And then the player gets a 302 redirection to that. The server code that we'll put up can also proxy it. A CDN would just give it to you. So in the demo, what you're going to see is contents and periods, and it's not Big Buck Bunny. Finally, a video that is not Big Buck Bunny. You're going to see some pre-built transcoded ads because we have to have something to play with, and maybe some malicious Big Buck Bunny anyhow, but only 15 seconds at a time. You're going to see a 350-line server, including comments, and a UDP service to forward beacons. One note on the UDP service. Turns out no CDNs nor Varnish speak UDP. So we use HTTP in those, but in our own service, the one that we use in production in Paramount, we use UDP because it's lighter, faster, it's fire and forget, whereas TCP, of course, is closed loop. An HTML dashboard, and I did not bring the fuzzy dice. So now's where I ask you this. Do you want to see the canned demo exactly as it'll be at Demuxed, or do you want me to fly live? Live it is. So this here is obviously Safari. And this here is, I'm going to pause it as soon as it starts up because I have to, obviously it's live. You just heard it squawking at me. This is 2 copies of Tears of Steel linked together because I needed enough length for that. I needed the length because, as you see, we've already loaded up to segment 17. Safari buffers a fair amount. That's an issue if you want to be able to beacon ads in the first minute. Safari's got, what is that, about two, maybe 3 minutes of buffering it's just done. And that's at 1080p. So we started up and we've immediately loaded up, Safari's immediately loaded up the chunk list. Sorry, there's cables everywhere here. So I've got here a filter, star M star. That's so that we only see what we care about. I'll show you there's a lot of other stuff there. So we're going to go right back to star M star. Okay, so here we have our chunk list manifest. And this is pretty cool in the sense that it shows exactly what I was telling you. We have up to segment 72 here, our discontinuity, and our new segments, which in this case, as you can see, here's my server, localhost 8082. There's our replacement beacon value, pi REPL val. It could be anything you want. It's just got to be something that won't show up with slashes around it as part of a normal host name. And then our one ad break 1. And we have another set of, oh, and at the end of this, you have another discontinuity, and we resume with Tears of Steel Part 2. The only reason I named them Part 1, Part 2 was so I get fresh numbering, and you could see this more easily. Normally, it would just start with 73, 74, et cetera. Then we have another ad break down below that, and we have another one further down below that. So you have your ad breaks. Here, we have a dashboard I built. Well, I and Jack built. And this dashboard will allow us to select ads. This area here is for when we receive beacons. There's a beacon client running. So I'm actually running 2 servers right now. I'm running a server here for the beacon client. This is beaconclient.go. And all it does is takes the messages from UDP and sends them on HTTP. And this is the actual reader server. So we're running 2 servers, and this is talking to the reader server and listening to the beacon server. So let's set some ad breaks. So again, we're up to segment 17. I'll show you that it actually runs a bit here. We've got actual video, and you can see we've just loaded a lot more segments here. So we have choices here for ad break 1. They are smash, arrow, spikes. Arrow. All right, we'll choose arrow for the first one and spikes for the second one, all right? And we can actually choose spikes later, and we can re-choose it as we want, or whatever we want. We can choose the second one later. So now we're going to resume the playback of the video here. And again, you see that here we're looking for segment 72. We're currently at 27. So we've got to go about 6 minutes in. And where am I now? 5:17. Okay, great. So here you are. You can see here we got to segment 72. What did we load after segment 72? We expected to load ad break 1, ad break 1, 1, 2, 3, 4. What we got instead was arrow init 0, 1, 2, 3, right? So how did this happen? Let's pause this so we don't miss any of the marvelous action. And over here, you will see we also fired the beacons. So the segment mappings we did when we chose the ads, these showed up, and we set one ad break 1 to be defined as localhost big buck arrow init. And over here, you see that that's exactly what we got, big buck arrow init. But when it actually did that, we got a beacon for it. And this beacon is what we would use as a signal to start bidding out the next ad break and freezing this ad break. So let's go back to this and watch that it actually works. I'm not going to try to fine-tune too far how far I push forward because I've learned that it's way too easy to go past that. So if you don't mind, let's just wait the 15 seconds. While we're doing it, anybody got any questions for the next 7 seconds?
The sound of this part is the best part of the movie.
Oh. And back to the show. And the thing about the Big Buck Bunny is it is a demux requirement. You are not allowed to do a demo at demux without Big Buck Bunny. It doesn't, even if there's no video in your content, you have to have Big Buck Bunny. All right, so what we've done here is you've seen that we have now loaded up and hit those segments and redirected to them, and there it was. We've got the beacons here. I'm going to show you one more thing. Does anybody here want, do you still want spikes or do you want me to change it now that you know the video's already been loaded and changed? We could switch it to smashed. Anybody care?
Change it.
All right, so we're going to go to smash. And now we're going to move this guy closer to 12 minutes. I may need to put on my glasses to do that. What are we at, 9, 10? Okay, let's see how far down we got. Okay, go another few. So this one will be at 12:15 because we had a 15-second ad in there. But you can see here, look, we got to Tears of Steel Part 72, and then we got to Big Buck Smash, which is pretty cool. So we're at 11:49. I'm going to try to jump just a little bit forward, and you will see the smash. And hopefully now you can understand why there's some Big Buck Bunny there. I chose the bits you never see in a demo. But that is the demo. What you just saw is that we managed to decision an ad after you'd already seen other segments and right before the ad was served. And we did it, in this case, with a legacy player. This is Safari, unmodified Safari. Not using interstitials, just unmodified Safari. It'll work on anything. I'll come to in a moment why you don't want to do this. Well, actually, I'll come to it right now. Oh, and also, if I go back to the beacon server, you'll see that the beacon server fired off those beacons. That's the beacon server. So let's go back to the presentation. Let's go. So you don't want to do this if you can avoid it. And the reason you don't want to do this if you can avoid it is because it requires a very precise ad break shape. Or you have to build in knowledge of it. In this case, I'm using 3 4-segment or 4-piece ads of 15 seconds each, which is great for a demo. But in real life, we're likely to have ad break number 1 being 15, 30, 15, ad break number 2 being 30, 30, 15, ad break number 3 might be 3 30s. In order to handle that gracefully with this, you have to have all the discontinuities baked in. The same ad break has to be used or pre-baked in for every program, or you have to know about them. And then you have to track the ads rather than the ad pods separately. And most ad decisioning processes don't do it that way. Freewheel expects to give you the entire ad pod, not ad by ad by ad. You can still extract them and do this, but it's not how it's expecting it to work. So that's problem number 1. Problem number 2, the segment count really is frozen at manifest time, so you have to get that right and be consistent with your lengths. That's not generally hard, but anybody who's dealt with video for a long time knows that, okay, these things vary sometimes. If it goes over just a little bit, you're likely to run into a new segment. Your audio and video have to be consistent. You can't like have the audio go into a slightly longer segment than the video. Oh, there's something following me there. Is that the camera? I've probably been driving any viewers nuts. so that's a big deal. Solid fill rates. This is really important. Actually, fill rates is what this is all about, too. So a fill rate is how many of your ads you manage to sell. Believe it or not, in our industry, 65% is a really good fill rate. Pluto doesn't get to that very often, and that's only selling 2/3 of the spaces. Why is it so low? Partly because there's limited, what we call inventory out there, only so many ads people need to sell. Partly because Paramount does a really good job of making sure we don't sell competing ads in the same slot. You're not ever going to see a Honda and a Ford ad in the same ad break, ever. It just doesn't happen. We prevent it. So those things happen, but also, remember, we only currently give you 800 milliseconds to do that bidding. You need more than that to do a good fill rate. Using this technology, you can get that fill rate up to 95%, no problem, because you've got like 30 seconds to do that bidding. That's a huge amount more. It turns out if we give you just 3 seconds, you easily get to 90%, but you're still not getting to 100. 100 is really, really, really hard to get to, especially after we filter out all the competing ads, you know, like the Ford versus Honda. What do you do then? In our case, health ads. We sell content. We've got Maverick, we've got Halo, anything new coming up. We just need a bunch of pre-built ads already ready. If we don't fill that space, we can default to something else. That's important for this. So the thing is, none of those problems happen with real interstitials. If you can use a real interstitial, you can still use this technology. But instead of pointing at the segments, you point at the interstitial. And then you don't have to worry so much about the fill rates because the length doesn't matter. The timing might throw off a bit on the manifest, but it's self-healing real well. The fill rates, it just doesn't matter at that point. You don't even need to match the codecs as well. You don't need to get the segment counts correct. You don't need the same ad shape everywhere. So if you can, use interstitials. They really are much better, but this will get you so much more revenue off of legacy devices than you can get otherwise. And that's really where we want to be so we all can keep making money. And that's my presentation. So questions?
So if I'm understanding this correctly, it gets resolved whenever the player goes to load that segment? Is that when it gets, like when it exactly does it resolve into the content?
So what happens is right after we serve the manifest or any time before the player hits the ad break, we are able to decision the ads. That's the resolution. The player just doesn't know about it until later. So going back to this diagram, and this is a good question, going back to this diagram, this part here is when the player finds out. We've already made the ad mappings, but what we've done at this point, every ad break has the same ads. The player hits a specific ad break, those ads get frozen, and this beacon lets us go get new ads for all the other ad breaks. So the resolution temporarily happens as soon as we serve the manifest or when we are in an ad break for the next ad break.
Okay.
But the player only finds out about it and locks down which ad break it is when it gets to it.
So, wait, so the beacon lets the ad server know, like, hey, I need an ad?
The beacon lets the ad server know, hey, I've started an ad, so you need to lock this down right now. So here's why. So if we go back to the idea of the periods, you have 5 ad breaks, let's say. And you have, say you're playing a Honda ad right now. So all 5 ad breaks have the potential of playing that Honda ad. It's which ad break do you hit? If you skip forward, you say, I don't want to see these first scenes, I want to see Tom Cruise on the motorcycle or whatever. You skip forward over all the other content, the ad break you're going to hit will still have the same ads that you would have seen in any other ad break. But as soon as you hit it, it now knows, okay, the ad break at 45 minutes is the one that has these ads. It has to freeze them there in case you back into that again so that you have the right segments there. You shouldn't be able to. Our players prevent you from doing that, but you still have to allow for wonkiness. So we will freeze in the database there, in the key value dictionary. So we have, remember, 1 ad break 1, and then the second ad break was 2 ad break 1. So if we hit ad break 3 first, and then they back up to then see some love scene or whatever, 1 ad break 1 hasn't been decisioned yet. It has potential but 3 ad break one is frozen on that Honda ad. Then while you're playing that Honda ad, maybe we give you a General Electric appliances ad and some other things like that. Whichever ad breaks you go to other than that ad break afterwards will have that ad. So the resolution is disconnected from the freezing and display.
All right, I got a question for you. Well, okay, sorry about that. 2 things. Why aren't we using interstitials today? Is question 1. Why don't, if they're so much better, why don't we just use that? I already know the answer, but. And the second question is, can you talk a little more about orphan ads and the lower CPM that you get when you orphan them, and why that's so critical to the company's monetization? And especially, we have, you know, you mentioned the pause for dinner on Maverick. You know, I think a lot of times the user action is to bail during commercials and orphan the entire pod. So just in that sense, what's up with orphan ads, and why not use interstitials today?
Okay, great. So interstitials are a fantastic development, but in Dash, they aren't very reliable yet, depending on the player. I'm not sure, there are other people who would know, but I heard at IBC that they're doing some new changes to Dash on interstitials in December. On Apple, again, they didn't even exist to the public consumer a year ago. They were in the spec, but they weren't released. Device fragmentation, that's what we call that. That's device fragmentation. Prevents interstitials from being a broadly supported solution right now. But also, a lot of us are serving communities other than first world tech communities like the US. If you're selling ads in Brazil, you have to support really low power devices, especially like General Instrument cable box clones. And those things will never support interstitials, whereas the pseudo-interstitials will run anywhere. And great question about the ad orphans. Ad orphans are really one of the biggest problems we have. When we sell an ad, when the video bidding starts, we have, let's say we have 6 ad pods and maybe 90 seconds average, so we're talking about a lot of ads at that point. I mean, we're talking about 24 ads. And there's a fair amount of overhead involved in selling them and filling them. There's not just the processing overhead, there's also the tracking and administrative and the refunds or not charging them and all that. And remember, those ads have beacons in them that get fired and checked. So there's a lot of bookkeeping. And we want to make money from them. Again, with Top Gun Maverick, you know, it's 2 hours long. That last ad segment is way off at the end. We get paid less for something that's going to be 2 hours out, not just because it might not show, but also because they might not care at that point. Advertisers want that ad right now. They've got their own studies going. This bidding is real time, and they want it closer to some event. So that matters. Also, ad orphans, another problem with the ad orphans is, as I said, you're watching Top Gun Maverick or whatever, and you pause for a while. This isn't really an orphan problem, but it acts like an orphan to us. You come back much later, same manifest. That ad might be that bidding for that ad might be 3-4 hours ago. We're not getting paid for it. It has expired. You saw it, but we don't get the revenue. The beauty of what we're doing here is we aren't showing you any more ads. You see the same number you were going to see. It's just that we make a lot more money from them. Remember, we're making more money because of the better fill. We've gone from 67% to 95%. That's 50% more money with no more ads. And we're getting more money per ad because they're showing sooner and because they are, oh, I forgot the other reason already. Well, they're showing sooner. That's a big reason right there. so that's a big, I'm sorry, go ahead.
No, you finished?
So the bottom line out of that is that we're dramatically improving the revenue with the same ad load.
Yeah, it's fantastic. It's a great thing. We got.
So you're saying they're being seen sooner. Is that because, again, I'm sorry, I'm his significant other, and I have no idea what he's talking about. But
so what I'm saying is that between when you bid the ad out and when it's displayed.
No. So you're saying that. So now they've gone on, they had their dinner, and then they're coming back. Is the ad being rebid now? to be shown in 15 minutes?
The moment they hit, I would imagine we certainly could at that point.
Right, so
It would
that's-
depend on what the player does. In my case, this code is only 350 lines long, so it's not going to do that. But you certainly could just build into it, hey, yes, at this point we're going to rebid the ads every so often until that session is dead. And actually, let me show you all the code because I want you to see how elegantly simple this is. Does anybody here want to see the code? It turns out nobody wants to see the code.
No, I'm sure people. We got a couple more questions too, and we have plenty of time. I just want to say you said something about that old devices have versions of code on there that don't take new innovations. Does that happen really?
I don't. I've heard.
Yes. All right, let's go to our next.
So in the manifest, you have the redirect URL that can be running on the edge or whatever. Isn't that a big hint for ad blockers to tell it's going to be an ad and don't show it?
It can be, and you might not do it this way. So you're referring to here.
Yeah, I'm referring to that, yeah.
And that is a potential concern, but again, it doesn't have to be there. This runs, so I can run the same server code, and right now, if you go back to my browser, if I go back to my browser, right now this code, we are looking at localhost 8080 tiers of steel here, basically, but I could just as easily point everything through that server. And I have pointed everything through that server for other earlier demos. Here's why you don't want to do that, and here's why you do. So this is a great question. Economics. CDNs are expensive. They're actually cheap, but CDN edge compute is expensive. Whenever you do anything on the CDN with edge compute, you generate what they call an event, and every event is billable. So if I hit the CDN compute to see, hey, do I have this token? And you have to do it for everything, or you won't know if you have that token, right? That's a CDN event, edge event that is billable. And then you have to look this guy up, and that's a key value lookup that is also billable. And every time you write to the CDN, it's all the CDN key value, it's also an event and billable. Trust me, I've been through a lot of this. So the reason why I built it this way in this demo was to show that there's another way to avoid those costs. On the bright side, ad blockers will probably crap out if they get bad segments missing. So that helps, because it would work better with interstitials than it does with this. If they do that, if they block that, the video player is usually just going to say, hey, I don't have the video, crap. So you do have that advantage to this. But yeah, you can make the balance between that. And also remember, these can be at the same place as long as you have that tag. It's just a matter of where are the economics. Maybe you'd say to the CDN, hey, this path, here I'm using logic for this path, but you could have the CDN directed internally for a path inside it, and then the host is not blockable. Anybody else?
So sorry, forgive my ignorance on the ad stuff, not my domain. I didn't know the ads expired.
Yes,
you didn't
absolutely.
get paid even if they're shown. So I'm trying to understand, like, probably outside the scope of this talk, but somewhat related, is what's the evidence that the ad was shown, and how does it expire? Like, is the beacon the evidence?
Perfect,
and
perfect.
if it's too late and it's
This is a really great question. So when the ads are bidded, the bidding servers, I'm not going to go into all the technology behind it because there's a lot of words that they're special to that chunk. But the ads get assigned basically a GUID that is inserted into them, 4 GUIDs. You started the ad, you're a quarter through, halfway through, 3/4 through, and you finish the ad. Okay, that's 5. Obviously, I need a computer. So there's 5 GUIDs basically in it that are in ID3 tags, and in Dash, that ID3 tag is wrapped in an e-message box. When the player, and they require a special player, so our Avia player has the Google IMA SDK. Actually, it's a different SDK now, right? Yeah. So it hooks into the ID3 messages. When it gets those notifications, it sends them off to the appropriate beacon receivers. In the years past, it used to be Oracle Moat. It's Open, who is it now? Open somebody? I can look it up. I don't have to worry about that server. But there's a couple companies that are trustworthy, sort of like, almost like the Nielsen's of ads. And they will receive these beacons that have already been set with basically that GUID for those ads. And that's how we get paid. And yes, they absolutely expire. These GUIDs are related to the ad sale. So they'll know how far through the ad it got. They'll know. Now, the interesting thing also is you saw that we saw I beaconed it before the ads displayed, right? But the players beacon it on the presentation timestamp, the PTS. So we will get notification on our server as soon as the player has requested the packets, but the beacon servers, the advertising trackers, get it only when it is actually on screen. That's what the PTS is for, the presentation timestamp. So if those come after the period that the ad is valid for, you're seeing the ad, the beacon fires, they know that somebody saw the ad, but they don't care. They don't have to pay for it.
So first question is, how do you deal if the last segment is less than 5 seconds? Because you pre-announce the extreme 5 seconds when the player is loading the manifest. So how do you deal if by lack of chance, the last segment is like, let's say, 4 seconds and not 5?
Yeah, actually, it turns out most players that we use, at least, are pretty good at pretty quickly self-healing as long as it's fairly close. Ads are usually within less than 1/10 of a second of the target length. They kind of have to be. And the players are pretty good at self-healing within that. But if it's further off than that, it'll be a problem for a bit.
Yeah, because in Dash you have like a 50% tolerance. So if in my example, if it's like 2 seconds, I think it's probably going to be maybe problematic. Okay.
Yeah, and I actually did cover that here at the end. It requires precise ad break shape and precise ads. That is a big concern and why I think you should use interstitials whenever you can. And what we will be doing is using interstitials on any player that supports them, and maybe using pseudo-interstitials on the other players, depending on the market, or maybe just not doing it and just inserting the ads up front. You don't have to use pseudo-interstitials to still take advantage of this technology for interstitials. You can still get the late bound ads, which is what I'm calling it when you decision the ad after the player started, with interstitials, and that's really your happy spot. Interstitials are great. Use them if you can.
Okay. Second question is like one of the benefits of interstitials is like you can prefetch your ads and you have more time for decisioning. So in your approach, do you have less time for decisioning, or can you also do like prefetching of the ads just up until the point where the player is actually requesting the segment redirect?
So what our general plan was, and everybody's going to have different logic they put in place, presumably. Our logic consists of this. Once you hit an ad break, you're trapped in it. We don't let you back out of that ad break unless you just abandon the video. Your ad break is going to be at least 45 seconds. We got plenty of time while you're trapped in that ad break to decision, bid, stitch the next, or in this case, map, the next ad break. So as long as your player is trapping you in an ad break, you're good.
Thanks. Thanks, Tony.
Let me show you the code real quick before I get kicked off for taking too long.
Start the music.
So the reason I want to show you the code isn't that there's anything special in the code, but that there's actually nothing special in the code. We have this code, we've got a few structures, a bunch of structures. We've got some help files and so on, and the code itself doesn't really start until after line 100 here, and you can see it's pretty well commented. And it ends down here, including proxying, at 450. So there's only 350 lines of code in there, and the vast majority of it is error handling. Also, you saw the dashboard? That code, that same code, empowers this dashboard. We only have 3 chunks of stuff in this entire demo. The dashboard, the code you just saw, and this beacon client, which is merely taking a UDP and forwarding it to HTTP. That's everything. This is quick, it's small, and it works on edge servers just fine. It'll work with Varnish, as I said. It works on Fastly, Akamai. All of them can run it. I mean, obviously, you have to build it separately for each one, but it's portable. All right, thank you.